I'm so bored right now. What should I do today? Oh, maybe I should call Shaiz to hang out with me.
Hello?
Hello, Shaiz. Would you like to hang out with me tomorrow?
Sorry, I'm busy. Have you experienced this before? This situation can be related to our processor. Timetable can be overloaded by tasks, while processor can be overloaded by the process. It needs to be fixed. That's where scheduling policy comes in. It's a way the processor schedule the process so that every process can run.
There's two types of scheduling policies, preemptive and non-preemptive. Non-preemptive is when the operating system cannot disturb the process, while preemptive, the operating system can disturb the process.
In this video, we will explain about two policies, which is SPN and SRT. We take a look SPN first.
Since we know SPN is non-preemptive, we can just fill in the first process.
Next, we go for the process B. As we can see here, the arrival time is 2. However, in scheduling, there is process A in schedule. So, we know that the SPN is non-preemptive. Therefore, we place process B after process A to complete its execution.
So right now, process C, D, and E trying to run. But how do we know who run first? Process that have the shortest service time will run first.
For process D, the service time is 2, where the expected execution time is the shortest compared to the process C and process D. It will lead to the process executing. Process D will be filled in the slot 12 with service time is 2.
After that, process E run first because the service time is lower than process C. After running all the process, we can then conclude the finish time.
Now that we have learned about SPN, then I will tell you about SRT. S1 B will arrive. So what we're going to do is compare the remaining time for process both of them. As you can see, the service time for A is 4 and the execute is 2. So the remaining time for A is 2. When we compare with B, the service time is 7 and process B has not been run on the process yet, so the execution time will be 0. After that, we will get the remaining time, which is 7. So when we compare both of them, we can see A has a shorter remaining time. Process A will be selected to continue executing in the CPU. For the next process, we have process B is pending. So we look at the process C. The arrival time is 6. So we can continue the process B. As we can see, the 7 execute 2, we will get 5. For C, the service time is 5 and process C has not been run on the processes yet, so the execution time is 0. And then we will get the remaining time, which is 5. So when we compare process C, it got the same remaining time. So for this situation, we should take the previous process, which is process B, but we have to see the arrival for the process D, which is 7. So we can continue process B until the process D comes up. After that, we will compare B, C, and D. 2 will execute 0, so the remaining time for D is 2. So process D will go first. We got E have 3 remaining time, so E will continue execution. After that, we only have process C. That's all from me. Thank you.
As you guys can see, both policy have a different result. So let's see which policy is better, SPN or SRT. To know this, we need to look at the average normalized turnaround time. For SPN, first thing first, we need to find turnaround time. So the calculation is you have to take the finish time minus arrival time, and we simply got the turnaround time. Next, we calculate the normalized turnaround time. For this calculation, we need to take turnaround time and divide by service time, and we got the normalized turnaround. After using the same method to add the process, we can find the average. So what we need to do is we add all the normalized turnaround time and divide by 5 process, and that's the average for SPN. For the next policy, which is SRT, we still use the same method until we got the average. After calculating everything, we can conclude that SRT is better since the average normalized turnaround is lower. So that's all from us. Thank you for watching.